We are in the last lesson of this chapter 10.3. Its powers and rules of complex number in polar form. We start with the Moivre's theorem. If you have a complex number z in polar form, z is equal to r sus theta, or I can write it also in Euler's form, rei theta, with z not equal to 0, sure r is positive, because r is the distance, the length cannot be negative, then Zn is equal to Rnei and theta. So as I'm finding the exponent of a complex number. So to understand the theorem, I need to do a small example. So if I want to calculate 2 minus 2 radical 3i exponent 5 using the Moivre theorem, how are we going to calculate this one? I cannot You can multiply it 5 times by each other and then develop, but if it was exponent 10, 12, 13, so we will not finish. So it's better, the best way is to do the Moivre theorem to calculate this complex number. So first step, you need to change the Cartesian form to the polar form. So first I need to find the r. So it's radical x squared plus y squared. So it will be radical 16 is 4. Now to be able to find the argument, let's go back to review a little bit how to find the argument on this one is also a common mistake. If I'm in quadrant 1, the angle is arctangent y over x. So the angle is exactly the same as the calculator will give it to. If I am in quadrant 2, the calculator, if you put shift arc tangent y over x, it will give you a negative angle, but it will not give you the angle that you really need. It will not give you this angle. It will give you this angle. So how are you going to find the angle? So it's pi plus the answer of the calculator, as I'm doing pi minus this angle here, but because I'm moving counterclockwise, so it's gonna be pi plus the arctangent, the answer of the calculator. If I am in quadrant 3, so I will do pi plus arctangent, because the calculator will give me the answer of this angle. So how do you find the angle theta of this complex number? So it's pi plus arctangent y over x. And if you are in quadrant 4 here, the calculator can directly give you the angle and the negative and the counterclockwise like this. So if you do arctangent minus 1 here minus 2 radical 3 over 3 to give you directly the angle minus pi over 3. If you need it as a positive answer, you do 2 pi plus the answer of the calculator, because as you are doing 2 pi minus the angle minus 60 degrees. So it's the same. So I will take this answer for this angle here. So now I can write z in the form of in the polar form, sorry. So it's 4 ei minus pi over 3. And now if I want to find z4, so it's very simple. So it's 4 exponent 4. The question is z4 or z5? Okay, it's z5. I'm sorry, guys. Let me just fix it. Okay, so it's, if I want to find that 5, so it's 4 exponent 5 ei minus 5 pi over 3. And this is the formula, this is the rule. You can find the answer if you want using the calculator 1024, sorry, ei minus 5 pi over 3. Now you can also, if you want, ei minus 5 pi over 3. Also, you can change it to the positive answer. So you can write it as pi over 3, or you can also write it as algebraic form. It's linked to the question. So you can write it in the Cartesian form. You can keep it like this. So it's linked to the question what they are asking you to do. Now let's do another example related also to this theorem. So let's say here it's example 2. Okay, if it's given z is equal half plus plus radical 3 over 2i, and the question is to find all the powers, find all the powers zn for n belongs to z plus. And then the question is, part B, is to draw the complex number in the argand diagram. So I need to draw the argand, I write it capital, argand diagram. How are we gonna do that? So the best way to do uh, this this exercise, first I need to change, as usual, we need to change it to the polar form. So to be able to do it, I need to change it to the polar form. So you need to find r. What is r? It's radical 1 over 4 plus 3 over 4. So it's radical 4 over 4, so it's equal to 1. It's easy. Now I'm in quadrant, quadrant 1, so it's very easy now to find the angle. That is as it is arctangent y over x. So arctangent is equal to over 2 over half, so it's arctangent radical 3, so it's pi over 3. And now I need to find z2, z3. So let's start. If I want to find Z2, what's gonna be Z2? Sorry. So what's gonna be Z2? It will be 1 squared EI 2 pi over 3. Yes or no? So it's, as I'm saying, it's EI 2 pi over 3. Now let's continue. So the first, let me just write here, Z1. When I say that exponent 1, so it's the first one, I'll write it here. So Z exponent 1 or Z, it's E I pi over 3. No, Z2. Now if I want to find Z3, it's 1 cube, so it's 1 EI 3 pi over 3. When I say 3 pi over 3, it means EI pi. Okay, let's continue. When I find Z4, so 1 exponent 4, so it's 1 EI 4 pi over 3. You will tell me, Miss, where are we gonna stop? We will stop when we are back to this value here. So I will continue now. Okay, if I want to find out here is that 5, so it's equal 1 exponent 5, 1 EI 5 pi over 3. I'm still in the unit circle. How I will know that I didn't exceed the unit circle. So if I do 5 times 180 divided by 3, I will get 300. I'm still less than 360. Now if I go to that 6 and I will do it, it will be EI 6 pi over 3, so it's EI 2 pi. So I am back. EI 2 pi, it means I am on the origin. I'm back to the, so it's equal 1. So I am here. So it means, and then I will stop, because if I will continue that 7, I will go back. I will continue. I'm repeating. So what is my period here? My period is 6. My period is 6. Now, how are we gonna draw the argand diagram? It's very easy. So I'll do my unit circle. I'm sorry, guys. I want to add a page. Okay, so I will do my unit circle here. And it's very easy. Let's say, so the length here is 1. The R is 1. So I will start. The first one, it was Z1. It's 6 pi over 3. Pi over 3 is 60 degrees. 60 degrees approximately here, because this is, if I divide this in 3 parts, so I'm here. Okay, so this is Z exponent 1. Now, that squared gives me EI 2 pi over 3. So it's here. So this is Z squared. Z exponent 3 gives me EI pi. So this is Z exponent 3. Z exponent 4 gives me EI 4 pi over here. So it's approximately here. Opposite to it. If you see, it's going to be opposite to it. So this is Z4. Z5 is going to be opposite to that too. I'm not drawing it to scale. So this is Z5, and the last one, Z6, is opposite to Z3. So if I look here, this is the argand diagram, and I can see that my period is 6. Now let's move to the last remark in this lesson, and then we will finish. I will do the remark with a small example, and that's it. So I'm just checking the time. I still have 5 minutes. So the remark is the following. If you have Rn cis theta is equal to A cis alpha, how are you gonna find what is R and what is theta? So Rn gonna be is equal to A. It means R is the nth root of A. And here if I have, sorry, it's n theta. And n theta is equal to alpha plus 2k pi. You need to be careful for that. Plus 2k pi. So it's going to be theta alpha plus 2k pi. To understand this remark, I will give you an example, and that's it. I hope that I will be able to finish the example. So, example. So, if I have Z4 is equal to minus 8 plus 8 radical 3i. Okay, I need to draw the solution on the Argand diagram. Yeah, we need to find all the possible values of z. To be able to do that, it means I need to find r and I need to find all the thetas. So instead of that, I will replace it, the best way, I will replace it by r ei theta. So REI theta 4 is equal, and I need to write this one in polar form. So you need to find R, so it's radical 64 plus 64, so R will be 16. So it's 16, and the angle here, X is negative, Y is positive. It means I am in quadrant 2, so I will do shift arctangent, but here according to, so I will do pi plus the answer of the calculator as I'm doing pi minus up, because it will be pi minus pi over 3. So it will be 16 ei to pi over 3. And now I will compare. It means I have R4 ei for theta is equal to 16 ei to pi over 3. And then I have R4 is equal to 16. It means R is equal to quadratic the root of 16, so it's equal to 2. How we do that? Because 16, it's 2 exponent 4, okay? And what's gonna be for theta? It's gonna be 2 pi over 3 plus 2k pi. And all what we need to do, we need to find all the thetas related to this case. So I will have theta is equal to pi over 3 over 4 plus 2k pi over 4. It means it's equal to pi over 12, yani pi over 6. I just try to finish quickly, plus k pi over 2. And to find all the thetas, I just start to take the k's. I take k1, k2, so for k is 1. So what will be the first complex number? Z1 is equal. The r is the same, it's 2. K is 0, I'll start, sorry. So 2k is 0, so the angle is pi over 6, cis pi over 6. Now for k is equal to 1. Z2 will be equal to what? 2 cis, so it means pi over 6 plus pi over 2. I need to add it, so it will be 2 pi over 3. Now for k is equal to 2. I have that 3 is equal, you can write z, z1, z2 if you don't want to mix the numbers, it's okay. So 2 cis, now instead of 2, I have pi over 6 plus pi. It means it's 7 pi over 6. So 6, 7 pi over 6. I'll stop when I'm repeating. I will continue until I finish. Oh God, what I did here. Sorry. And now I'll continue here. Now for k is equal to 3, I will have that 4 is equal to cis. So I'm pi over 6 plus 3 pi over 2. It will be 5 pi over 3. And now if I take k is equal to 4, it will be pi over 6 plus 4 pi over 2. It means plus 2 pi. So I'm back to this angle. So I stop here to this one. So I have 1, 2, 3, 4. And those 4, I will draw it on the